Welcome back to Geometry Classroom. Today we'll talk about inverse trigonometric ratios or inverse trigonometric function. As objectives, we define and identify inverse trigonometric functions and use the values of inverse trigonometric functions to find angles. Inverse of trigonometric ratios or functions is useful in many fields of activities, right? It's very useful and used in fields like topography, electronics, water navigation, astronomy, communication, architectures. So it's important to understand this topic. Now, for a better understanding of inverse of trigonometric ratios, let's look at this problem. Yeah, this is a new type or a new kind of trigonometric problem. So in this triangle, it says what is the measure of angle L? We have to find the measure of angle L this time. Interestingly, these problems can be solved using sine, cosine, or tangent. What do we know? Relative to angle L, right, we know the lengths of the opposite and adjacent sides. As we can see here, yeah, if we mark this angle, angle L, we need, yes, what is given? Is given this side, right, what is, which is adjacent side, and this side, which is opposite to angle L. So, because these two sides are given, we can use the tangent ratio. And we know the tangent of angle L would be the ratio of opposite side to adjacent, right? And opposite would be 35, and adjacent would be 65. Yes, that's the tangent of angle L. But look, this tangent ratio doesn't help us to find the measure of angle L, right? We are stuck. But there is a solution, right? So, what is the solution? We need a new mathematical tool to solve problems like this. Our old friends sine, cosine, or tangent aren't up to the task. They take angles, right? A trigonometric ratio takes an angle and gives the side ratio. Now, in order to find an angle, we need another ratio or function that takes the side ratio and gives you the measure of the angle, right? So, trigonometric ratio, like tangent, right, is applied to an angle and gives you the side ratio, right? Now, to find the angle, we need an inverse operation, right? So we need another function, right, that takes the side ratio, right, and gives you the angle, right? Like here, right? Yes? Good. Now, that's why we need an inverse of a trigonometric ratio or function. So, because we have three trigonometric ratios, we're going to have three inverse of trigonometric ratio, one for each trigonometric ratio. For example, for sine of an angle, we'll have an inverse of sine, which is denoted by sine of -1, right? So don't confuse this notation with the power of -1. It's just a notation. So the inverse of sine trigonometric ratio would be denoted by sine of -1 or arc sin of x. For cosine, we have the inverse of cosine, yes, which is denoted by cosine of -1 or arc cos of x. And for tangent of an angle, we have the corresponding inverse of tangent, denoted by tangent of -1 or arc tangent of x, right? Any of these inverse trigonometric ratios do the opposite of the original trigonometric ratios. Good. An inverse of a trigonometric ratio, it takes the side ratio and gives you the angle, right? Now, let's go back to our, original problem we had in the previous slide. Remember this problem, right? Now, we wrote tangent of angle L would be the ratio of the opposite side over adjacent, 35 over 65. Yes? Now, to find the angle L, we have to use the inverse of tangent, right? That is applied to the side ratio and gives you the angle. So, we can say L is tangent of -1 of the ratio of the side ratio, 35 over 65. Now, in order to estimate angle L, we need calculator. And I'll show you how to find the measure of angle L using Texans Inspire calculator. Yeah? So, here, to find the measure of the angle L, we press trig, right? And as we can see in the first row, right, there are trigonometric ratios. In the second row, there are their inverse. Yes? Now, because we work with inverse of tangent, we click on inverse of tangent, and you'll get on the screen the inverse of tangent. Inside the parentheses, we write the ratio of 35 and 65. How? We press Control and divide, and on top we'll write 35, in the bottom 65. And then you simply hit enter. And we get the angle, right? So the angle would be 28.3 degrees. Yes, so the angle L would be approximately 28.3 degrees. Good. Let's have a few applications, problems with inverse of trigonometric ratio. Now, in this example, given triangle, right triangle BAT, find measure of angle T. The angle T is denoted by X. Now, we mark the angle first, right? Before finding the angle, the measure of angle X, we have to identify what trigonometric function or ratio we use, right? Now, because 7, this side is given, right? So we know this side is opposite to angle X, right? So we say opposite. This side, which is another side that is given, is the hypotenuse, right? Hypotenuse is the side opposite or across the right angle. This is hypotenuse. Because the opposite side and hypotenuse are given, we have to use sine ratio, right? So we're going to have sine of angle X because, as I said earlier, the trigonometric ratio is applied to an angle, right? So we're going to have sine of X equals, let's say, equals here, the ratio of opposite side to hypotenuse, right? Remember the formula for sine ratio. So you're going to have on top 7, in the bottom 25. Good. Now, but we need the measure of angle X. To find the measure of angle X, we have to use the inverse trigonometric ratio of sine, right? So, remember, the inverse of sine, right, is applied to the side ratio and gives you the angle. So, you're going to have 7 over 25 equals X. Now, we use, again, the calculator. This time, we use the inverse of sine. We press trig. The inverse of sine is sine of -1. So we click on sine of -1. And we type the ratio of 7 of 25. So control, divide, 7 on top, in the bottom 25. And then we hit enter. So we get the angle, 16.26. So X, angle X would be 16.26 degrees. Good. Another example. Find the angle measure of a right triangle knowing sum of its sides. Determine the measure of angle W, right, to the nearest degree. So, we mark the angle. And first, we identify the trigonometric ratio, right, first. And then we use the inverse of that trigonometric ratio. Now, what is given? Is given this side, which is opposite to the angle, right? And this side that is adjacent, right, to the angle. Because these two sides are given, we use tangent of this angle. So we can write tangent of angle W would be equal, on top is opposite, right, which is 20. In the bottom is 83. Again, to find the W, we use the inverse of tangent. Yeah? And the inverse is applied to the side ratio, is 20 over 83. So let's find the measure of angle W. Again, we press trig, then we click on inverse of tangent, then we type the ratio of 20 and 83. Control, divide, in the bottom is 20, in the bottom is 83. And then we hit enter. So the angle would be 13.54, right? So 13.5 degrees, yeah, because it's to the nearest, let's say, degree. Let's say probably would be 14, right? 14 degrees. Now, the last problem, determine the measure of angle question, right? Let's say here, instead of question, put an x to the nearest degree. Again, we identify the trigonometric ratio. What is given? Is given the side that is adjacent to angle x, right? This is adjacent. And this side is hypotenuse because it's face to face or opposite the right angle. So this is hypotenuse. So because adjacent and hypotenuse are given, we're going to use cosine of this angle, right? So we're going to have cosine of x equals the ratio of adjacent over hypotenuse would be 13 over 20. To find the angle, we use the inverse of cosine. So x would be inverse of cosine of 13 over 20. Good. Let's find the angle. So again, we use trig. We use inverse of cosine, and we type the ratio of 13 and 20. We hit enter, and we get the angle. So the angle would be 49.45. So 49.45 degrees. Of course, if we round to the nearest degree, we're going to have around 49 degrees. So that's all we have for today. Thank you for watching my video.